Hello, welcome. Let's try to solve another Leetcode problem 1269, number of ways to stay in the same place after some steps. So let me first explain this problem. So we are giving steps and array length. So for example, if the array length is 2, so this is the array length 2, so it means we're going to have two positions from 0 to 1. So this is going to be the positions. Yeah. So we have a pointer at index 0. So this is our pointer at index 0 in an array of size array length. So this is the array length. So at each step, you can move one position to the left, one position to the right, or we will stay at the same place. Yeah. So giving two integers steps and array length, return the number of ways such that your pointer is still at index 0 after exactly k steps. So this is very important, exactly k steps. Since the answer can be really long, so we're going to use a mod. So let's just try to check the first example. So if we have 3 steps and array length is 2, so what are we going to do? So we can stay here 3 times. So it's going to be stay, stay, stay. It's going to be at position 0. Or we can go right. We can go to the right, and stay, and then go to the left. Yeah. Or we can stay right and left. We can stay here, go to the right, and then go to the left. Yeah. Or we can go to the right, left, and stay. So we go to the right and the left, and then we stay here. Yeah. So if we are going to check the result, gonna modular a big number. So basically, this is gonna be a dynamic programming. We're gonna use two variables. The first variable gonna be the position, and the second variable gonna be the steps. So let's just use the left. That means how many steps it is the left. So that is for our dynamic programming. As we're going to use a DFS, basically we're going to use a DFS with memorization. Yeah. So the condition is that we're going to check the left. So if this left equals to 0, so basically we need to check the position. So if the position equal to 0, it means it is a valid, it is a valid path. So if it is not at 0 position, so it is not a valid path. And we can also consider that what going to be the maximum positions, because for this left basically it is 500 according to the problem, and what going to be the maximum value for the positions. So the maximum positions can be 250. Yeah, but for us it's going to be the steps divided by 2. Yeah. So if it is more than steps divided by 2, basically this means it is not valid. So for example, the steps is 100. Can we go to a position more than 50? So 100 divided by 2, it is 50. Can we go to a position at 51? Definitely not, because if we go to a position 51, it means we used 51 steps. How can we use 49 steps to go back? So it must be 50. We're gonna from 0, we're gonna use the 50 steps to go to this position, and then use the 50 steps to go back. Yeah. So it means if it is more than 50, basically it is not possible. And then we're gonna use the 3 different cases. So at any position, we can go to the right, or we can go to the left, or we can stay here. Yeah. Now let's just try to use this idea to solve the problem. So we're gonna use a mod. It's gonna be 10 to the power of 9 plus 7, and we're gonna check a maximum position, so it's gonna be the steps divided by 2. Now we're gonna use DFS to solve the problems. So let's define the function as DFS, and we're gonna prepare the position and the steps. So here we're gonna use the position and left. Yeah. So if left equal to 0, basically we need to check the position equal to 0 or not. Yeah. So if the position is more than the maximum position, basically it's not possible, we're gonna return a 0. Now we're gonna decide to go to the left. So if we go to the left, basically we're gonna assign it as A. It's gonna be DFS with position minus 1 and left minus 1. So if this position minus 1 is more than and equal to 0, and then we can go to position minus 1. Yeah. Else, it means it's impossible to go to the left. We're going to set it as 0. Now we're going to go to the right as b. So it's going to be position plus 1 and left minus 1. So if position plus 1 is less than the array length, basically we can not go out of the boundary because the boundary is 0 and 1. Basically we cannot go to the position that equals to 2. Yeah, so that is why the position plus 1 should be less than the array length. Otherwise we're gonna set it as 0. So this is if. Yeah. And the third choice is that we're gonna stay here. So the position gonna be the same, but the left gonna be -1. Even if we stay here, we still consume the steps. It's gonna still be one of the steps. This is just according to the question. Finally, we're gonna return a plus b plus c. That's gonna be the total steps modulo a mod. Now let's just call the function. It's gonna be starting at 0, and the left gonna be the how many steps. Now let me just run it. Yeah, as you can see, it works. Now let me just submit it to check if it can pass for all testing cases. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. And the time complexity is going to be 500 times 500 divided by 2. So basically, yeah, it is the position times left. Yeah, as the position equal to the left divided by 2. Basically, it means yeah, steps square, and the steps going to be 500. It means 500 square going to be the time complexity for the problem. Thank you.